Great. Awesome. Well, good morning. Welcome. And today our focus is quanta and the meaning of quantum computation in a cosmology of light. And just as a little background, I've been having these meetings focus on musings of cosmology of light for well over a year. And typically the frequency was once a week, and then I cut it back to once a month. And so now I just do it on the last Friday of each month, and I choose a topic. And it's a few people who sign up. Today there were 14 people who signed up for this, but we've got 4 of us right now. So why don't we get launched? And the way I like to do it is that I can give a quick overview of some of the key concepts here, but I really want this to be interactive. So specifically, if whatever you may have read, you can bring up whatever comments you have, any kinds of questions that you have, and we can discuss it as a group. I can share my insight based on the cosmology of light, but I always welcome people's perspectives based on their experience or how they perceive things. So stepping back, if we focus on quantum computation, there's a few key devices that are important that I try to provide some preliminary readings from a cosmology of light point of view. So there's the notion of quanta, there's the notion of quantization, of computation itself, and phenomena called entanglement and superposition. And I've got these brief musings that were meant to be starting points for us to delve into this in a little more detail. And I can speak a little bit about them at a high level to get us started. So stepping back, cosmology of light, why is it a cosmology of light? So first of all, if we think about light, and scientifically, we perceive light as traveling at a constant speed in the physical universe of 186,000 miles per second. And that really is my starting point for the whole idea of cosmology of light, because the question to me was why? Why should light travel at 186,000 miles per second? That to me, that seems significant. Why not 100,000? Why not 200,000? Why not multiple speeds of light, and so on? So the fact that it's a constant speed in the physical universe implies that there must be some significance to it. And so the question to me was really, what is this significance? And if I were to begin to explore with different potential speeds of light, then what kinds of insights might I gain? And that really was the basis of this cosmology of light. So, as you've read, or you may have heard me speak before, or we've discussed before, is in my mind, I extrapolated, okay, let's take this speed of light and just hypothetically pose the question that if light would travel infinitely fast, then what kind of reality it would create. And so that then becomes a starting point. So in this cosmology of light, the hypothesis is that light's native state is where it travels infinitely fast. And then there's a number of other speeds that it can project itself at. The constant speed of light that we know of at 186 being significant for the formation of this physical universe. But there's other speeds as well. So it may project itself at a state where it's essentially not traveling. It exists at 0 miles per second. And the question is, what kind of reality would that create if you project it at some speed between 186,000 miles and infinite? Then what kinds of realities would it create? And so when you consider all these kind of juxtaposed realities, you come up with a cosmology, because there's different implications for the dynamics that may arise in this physical universe. So that's kind of the backdrop of the idea of cosmology of light. And in this, if we, from a thought experiment, and I'm going to pause after this, if we consider light to travel infinitely fast, just hypothetically, and we take some volume, imagine a very large volume, and you have light at its center, and light's traveling infinitely fast, then there's some things that we might be able to say about the reality that's created when that happens, because if light traveling infinitely fast, it's going to be present everywhere at the same time. So there's, in that reality, there's something that we may call all presence or omnipresence when light's traveling infinitely fast. If anything were to arise or disappear in that fabric of light, then it would be recorded in the fabric of light, and therefore light would have some kind of omniscience or knowledge of everything that's happening in its space. Since everything is connected in the fabric of light, there's a implicit harmony that exists because everything is occurring in the same nature. So that gives rise to the idea of all harmony or omninurturance. And finally, if anything not of the nature of light were to arise, it would sooner or later be subsumed or overpowered by the nature of light, and therefore there's an omniscience or an all power that also we can hypothesize might exist in that realm where light was traveling infinitely fast. And so then that becomes, in a sense, the starting point, or that kind of foundational reality when you consider that space where light's traveling infinitely fast. Let me just pause there and ask if anybody has any reactions, if there's any comments, because this is foundational to getting into the idea of quanta and quantum computation the way that I perceive it. So please feel free to share. We'd love to see your faces if you can share videos. That'll be awesome. And then what I'd like to do also is just have a brief round of introductions so that everybody knows who everybody is. And we can just keep it very brief. But before we go there, any comments, any questions, any thoughts on the framing of cosmology of light and the idea of a different kind of reality where light to travel infinitely fast?
Just a clarifying point, is the knowledge is omniscience and the
Omni,
overpower
yeah.
is omnipotent.
And sorry, and the what?
The knowledge is the omniscience
Yes.
and the overpowered part is the omnipotent.
Okay. Yes. Yes. Correct.
Okay, so there.
Yes, yes.
Okay.
Yeah. Any comments?
Margaret, what did you say the overpowered part was?
The omnipotent. Just that thinking of this in this way, right?
Mm-hmm.
As you lay it out, it's just thinking of it in this way, thinking of different realities based on this intermediate from the native to 186,000. It's like a different grouping of realities. Something that I wouldn't have thought of.
Yeah, exactly. So it's a different grouping of realities, and the hypothesis being that there's an influence of these other quote unquote realities here in this physical realm as well, by nature of light. Because if we assume that light in its native state is infinitely fast and everything else is a projection, then no matter what the projection is, light infinitely fast is going to exist as a contextual frame.
Contextual.
So therefore the reality that animates that frame is going to be present to some degree even here. So we're getting into philosophy and a little bit of metaphysics here, but I want to steer it towards the quanta and quantum computation. Before we go further, I'd like to just invite each of you to just briefly introduce yourselves, and then we can continue with the quanta and quantum computation. So we'd like to just briefly introduce yourselves, where you're from, your interest in this topic would be great. So Margaret, would you like to?
Yeah, I'll go first.
Yeah.
So I'm Margaret Faines. My background is a graphic designer, but I've also done quite a bit of teaching of meditation. So the two aspects of this, which are understanding light inner and outer light, and all that means, all that needs to be explored. And then putting that into visual form is something that I had been doing for many years, but this work is particularly connected to that. So obviously that's why when I can take a workshop, it helps me understand the conceptual side so that it stimulates my imagination.
Great, thank you. And I'll mention that Margaret and I are now collaborating on a project. We are doing a book together called Musings on Light. And essentially, Margaret is doing all the illustrations for the different musings that are based on a cosmology of light. So.
Well, that's fantastic. And as Pravir knows, I've known Pravir for several months now. I'm an investor and an advisor to companies, usually startup companies, and former financial and journalist, editor, correspondent for Reuters and others. And fascinated by the work that Pravir has done in his, is it going to be now 18 books on various aspects of quantum mechanics, and I'm interested from that perspective of his both novel and broad knowledge and explorations in this subject and related subjects. I'm curious, by the way, as a start-off question here, which may be showing a lack of understanding, but is there a way in which this principle affects our understanding of what might be a multiverses in the astronomical sense, and the way in which we conceive of how the theories of that impacts our overall understanding of the kind of the universe and the multiverse world?
Yeah, I think that's a great question, Sam. And I think certainly if we were to consider, after all, this is only a model, but in this model, if the native state of light is such that it travels infinitely fast and it can project itself at essentially in infinite different ways, then that would potentially, from this point of view, be the basis for having simultaneous or many different universes within that larger kind of contextual reality. So it's a point of view that would suggest that yes, you could have multiverses. It would be different from when we think about quantum physics, and I think maybe that's where you're coming from, because our conversations have been around that in the past. When we think about the view of multiverses, I understand from a quantum physics perspective, it's really that any action that's taken could have bifurcated, and the reality that we experience here is due to an action that we're aware of, but there could have been another action that's taken in which there could be a completely different bifurcation, and then there could be a number of split-off bifurcations that all create this massive idea of parallel realities that all have diversified from every instant to the next. So that's, I think, a view of the multiverse as I understand it from the quantum physics perspective. And so this would be a little different, because it's the point of view of you have one reality of light, but then depending on how light projects itself, it would create a different projection, a different precipitation of what's inside it. And so those would show up as different kinds of universes in a sense. So, yeah.
Thank you.
Sure. So if I just begin to focus on some of what this session is about and some of the readings, the idea of quanta, which we hear a lot about today. But in a cosmology of light, the idea is very simple. It's a bridge mechanism. So if we assume that light travels infinitely fast, it has therefore an infinite amount of information in it. And when it projects itself at a slower speed, then we can intuitively get a sense that because of its slower speed, there's in a sense some kind of information that is being gathered through that slower movement, and there's a threshold value that when reached, that information can express itself. That idea of the threshold value is related to quanta. You know, it's like everything that happens in our physical universe has a quantum reality because there's a threshold under which nothing can express itself. So there's a minimum amount of energy that needs to gather itself, or a minimum amount of information that needs to gather itself in order to express itself cohesively. And that idea is one of basically what quanta is. So in a cosmology of light, thinking about quanta as a bridge mechanism between one layer of light and another is really the simplicity of it, is that because we're saying when light travels faster than our speed of our known speed of 186,000 miles per second, it holds different kind of information in it. And that's some of the readings that we can go into, depending on where you'd like to go. We can discuss that a little more. But that different information that exists when light's traveling differently, when it gathers itself to express itself materially, then that's what really a quanta is. So it really is a bridge mechanism of translating information from one layer into a materialized reality that we can perceive based on our instrumentation in this physical universe.
What would explain the constant, assuming infinite speed, the constant, which, as you would say, is slowed down but significantly fast in terms of miles per hour or kilometers per hour, or however. What would explain that the constant is that for the observable light speed that we that science has often accepted?
So, one way to think about it in this cosmology of light is that so I propose that there's just mathematically, if we think about it mathematically, there's three quantizations that need to occur for that infinite potential or unity when light travels infinitely fast to express itself as infinite diversity. So there's three precise quantizations, and those quantizations, in my perspective, happen when light projects itself at a slower constant speed. So if we take light traveling infinitely fast, so we know, let me just step back here a sec, but we know another fundamental constant in our physical universes is that Planck's constant, which is h. And that's, in a sense, the smallest quantity by which any kind of differentiation, whether on a space scale or a time scale, can occur. So it's a threshold quantity, which in this perspective needs to be a threshold so that some meaningful information can appear, in a sense, whether on a time scale or on a space scale. But if we think about that relationship between C and H, to answer your question, then the way that I think about it is that there's an inverse relationship. If you look at any of the formula in science, you can see that there's an inverse relationship. So C is massive, H is minute, and they occur in formula in such a way that they're there's an inverse relationship between them. My hypothesis is that H is created because of C. So they're not two distinct constants, they're actually fundamentally related. But that's not something that's discussed or is proposed in science. But what I'm saying is that light is the fundamental basis from which many other constants arise. And H being a fundamental constant that arises due to C to answer your question, suppose you have light traveling infinitely fast, then h would be 0, because you've got, if there's an inverse relationship, and h, in a sense, you can think about h as being a mechanism which tells you how matter will form. If h is equal to 0, then no matter can form, right? In a sense, because there's no way for any energy or information to accumulate. And so we're saying that when light's traveling infinitely fast, you've got one integrated reality that exists everywhere. When light projects itself at a slower speed, h becomes a bigger quantity. And in my perspective, the h that we happen to experience in our physical universe is precisely what we need for matter to arise the way that it does. But for that to happen, light has to be a certain speed so that h can be a certain quantity, right? And so that's why c is 186,000 miles per second, because that'll give you a precise quantity, a constant for h, which allows matter to arise the way that it does. If h is a smaller quantity, suppose, assume h to be smaller than it actually is, then in this point of view, in this cosmology of light point of view, matter would show up differently. It would show up as a wave, because it's still an integrated thing. It still holds itself, but it expresses itself differently. And so what I'm saying is that if c is faster, h is smaller than it is here in the physical universe, then the matter that shows up is in a wave form, right? And we know, for instance, wave particle duality is something that we talk about in quantum physics, where you've got matter or you've got light that actually have wave particle duality. And again, there's no philosophical reasoning as to why that might be the case. So I'm proposing a reason as to why that's the case in a cosmology of light. And similarly, if you approach a speed of light that's closer to infinity, but way, way, way faster than c, then h would still be a finite quantity, but would be really, really, really small. And if it's really, really, really small, then the matter would express itself as a vast field. So you get this idea of a quadrality of phenomena where, we already know, for example, that matter can be a particle, matter can be a wave, but I'm also suggesting it can be a field or it can be a block, based on if you kind of think about light that could exist at different speeds simultaneously. Let me pause there. That was a lot, but
That's a lot, but it's a phenomenal jaunt through the space. Thank you.
yeah, and it's and that's part of the readings that I don't know to what you may have read, the 3 or 4 that I had suggested, the readings, but the whole idea from getting from unity to diversity and using our at least how we interpret or how we perceive C and H. And what I'm doing is just adjusting what C and H mean, so that there's multiple ways to perceive them, and that's essentially what I'm doing. I'm just saying that it's not necessary that it's a completely fixed constant. It is in our physical universe for a particular reason, but they could have counterparts that are part of their deeper reality in a sense. So C, light, as I'm proposing, is something multidimensional, and the speed of light, C, is one way in which we understand how C shows how light shows itself up for us, but that's not the full reality of C. So similarly, H, there could be a deeper reality to what H signifies. And so in a cosmology of light, we're going into the deeper essence of what H could mean, going all the way back to that layer where light travels infinitely fast. Because there H is equal to 0 and matter can't form at all.
So, Prabir, going back to the quanta idea.
Yeah.
So are the quanta bridges of all these potentially different multidimensional realities and differences in C and H? The quanta
Yeah.
can be the bridge of all of that.
Of all of it. So That's what I explore in the books that I've written.
Mhm.
And even I try to hint at with some of these musings, is that if we think about space, time, energy, gravity, which are fundamentals in our universe, we've given them primary places. But what I'm suggesting is that space, time, energy, gravity all express themselves through the device of quanta. They're all emergent from light. So if you think about, so let me, this may be, let me know if it's too much or how to break it down. But if we go back to the idea when you have light traveling infinitely fast, there's four properties that I proposed exist in that reality. We can roughly call them power, presence, knowledge, and harmony. From the idea of omnipresence, omnipotence, omniscience, and omninurturance, we can simplify those to say that light has implicit in it four properties, which we call presence, power, knowledge, and harmony. Is that, does that make sense so far? Yeah.
Yep.
Now, if we think about that precipitation that can occur, that can continue down and occur physically, then in a sense, when we take that line of precipitation of knowledge, then the way I see it is that space is actually expressing the principle of knowledge, because in space you have infinite number of seeds that all, in a sense, express these different core ideas that will mature through the play of time. And in that maturation, there's a change in energy. So energy is fundamental. And the idea of gravity is simply that you have certain seeds that will correlate with other seeds more tightly. And so there'll be collective realities caused by a relationship between seed and seed, but it's all occurring in space. So space-time, energy, gravity, from this point of view, are nothing other than the four properties of light. Like the space being, in a sense, a projection of what knowledge is, time being a projection of what power is, because anything that's contained inside a seed will inevitably become real. Um, Energy being the idea of presence, because it essentially takes something that's subtle and makes it material. And gravity being the idea of harmony, because you have a relationship between different things as they show up materially. So everything, if we look around us, everything is all about relationship. So even at the micro level, at the nano level, you've got quantum particles interacting in a certain way that then form the basis of atoms, and you've got a very tight relationship there where quarks, leptons, Higgs boson, and the bosons interact to create, in a sense, an atom. An atom then becomes the foundation for the next level. The point being is that you've got all four of these properties of light that project themselves to uh, create anything that materializes. So, how are we doing so
So
far?
thinking about this bridge concept,
Yeah.
and I, I, is it fair to say it's an interpreter?
Yes.
Okay.
Yeah.
Okay.
Yeah.
So I was trying to think if there was something like something that I could think of that I maybe had an experience with that might be a little easier, like
Sure.
a bridge
Yeah.
to a bridge.
Yeah. Yeah. I mean, so Margaret, just because we've interacted, and I don't know if the word Maya means anything to you, the concept of Maya.
Yeah.
But that, so that's how related philosophically is that, in a sense, Maya takes infinity and makes it finite, right? So in that sense, you can think about quanta as being a vehicle for Maya to take infinity and make it finite. Because it's collecting information in a certain way. It's also very precise information, and it's materializing it in a certain way. So to me, there's a tight relationship between the way Maya operates, or what Maya is, and the concept of materialization from something that's immaterial.
That's very helpful. I'm gonna mute because there's some.
Yeah, disturbance. Yeah. Okay. What, how would we, what other questions or from the readings? Let me just pull them up, real quick, and let me share the screen over there, and we can go in. Um, so let's see. You see just reality check, Quanta, and the Big Bang. Yeah. So what we could do is just briefly go over the core concepts here, because they build. So the four readings that I suggested for this was Quanta and the Big Bang, the logic of triple quantization, reframing the basis of quantum computation, and the purpose of entanglement and superposition. They build on each other. So my question is there a particular area that you'd like to go into that we can discuss in a little more detail from these four ideas that are posted here? So again, this is, what on earth has a Big Bang got to do with quanta? So that's one connection. What is this triple quantization, the mechanism of it? And to me, that's, in a sense, the deeper idea of computation, because there's always infinite potential or possibility that's being arbitrated into reality. And so what this here is just the mechanism by which that arbitration takes place through quantizing itself more and more materially. And so that's what we're really talking about here. And then the idea here is coming to quantum computation, which, if you think about today's view on quantum computation, then in my perspective, I see it, in a sense, being heavily constrained by digital computation, because we're trying to solve the same kinds of problems, in a sense, that we solve through digital computers. But my point of view is that we're not thinking about quantum computation from what it really could stand for, because it's fundamentally creative as opposed to constructive. So if we think about any kind of computer, digital computer, it's a constructive mechanism. It's taking like a bunch of instructions and it's running them through, and it's then constructing a reality based on those instructions. But if you think about quantum computation that might be happening in these layers of light, then it's fundamentally creative, because there's just possibility that's materializing. And the fascinating thing is that the way that matter arises, and again, this is something that hasn't been seen by mainstream science, but I pointed it out, is that there's an implicit order that can relate back to these properties of light in the way that quantum particles show up, in the way that atoms show up, in the way that cells show up. And the example I use is that in cells, you got four molecular plans that, in fact, there's a one-to-one mapping between the idea of knowledge, presence, power, harmony, and the four molecular plans that show up in a cell. So the idea that you've got these four, in a sense, deep levers that are constantly the basis of how things are showing up, means that there's a computational relationship. And so we got to think about quantum computation differently. It's creating based on these four things, but infinitely. And so it's fundamentally different from the idea of digital computation that's constructing based on regurgitation of set kind of formulas, in a sense. So before I move forward, any comments on that or thoughts?
So taking this in, that these aspects, these four aspects keep showing up. And you're saying that understanding that gives you a different understanding of quantum computing. Is there I guess I'm always trying to make it a little more tangible, but is there a sense of how that computing, how you would compute?
Yeah. Yes, actually there is, and so Margaret, some of the work I've done that Sam is aware of. So I actually filed for a patent.
Okay, I had heard that.
So I've tried to make it pretty concrete in terms of how we can interpret quantum phenomena differently. So my point of view, and this gets into the fourth piece that I had suggested on superposition and entanglement, because superposition and entanglement, if you look at it, I just want to point out one key difference between the way that mainstream science and quantum physicists thinks about it and how I think about it. So in mainstream quantum physics, you are creating the phenomena of entanglement and superposition from the ground up. That's a very valid approach, and I think is got to be lauded. What I'm saying is that if you think about cosmology of light, superposition and entanglement already exist, and they exist abundantly. So the very fact that let's just think about the silver atom. It's got a atomic number of 47, meaning it has 47 protons in its nucleus. And no matter where that silver atom occurs, it's going to behave the same. That implies that there's entanglement between all silver everywhere, because otherwise it couldn't behave the way that it does, no matter where you put it. Okay, so what I'm suggesting is that entanglement and superposition are naturally occurring phenomena that exist in abundance already. So when you think about quantum computation, you don't have to create superposition and entanglement. You have to leverage what already exists differently. So you compute based on this phenomena that already exists. So if you're designing a quantum computer, you don't want to create from the bottom up, hey, I'm going to create superposition entanglement. You want to recognize that superposition and entanglement occur, and you want to compute differently based on the existence of this as a fundamental principle of nature. So it's different, right?
That makes sense.
You're saying that it exists. You want to leverage it. You don't try to create it and then say, okay, what can we do with it? So it's different. It's a different way of thinking about computation, right? And so the computer that I've designed on paper actually takes things like superposition and entanglement and tunneling and annealing, which are considered to be four fundamental principles that have to exist in quantum computation. And it's just using them differently to do different things, to potentially do different things, because the idea is that they already exist. So how do you recognize them? And the gates that I've created actually have to do with recognizing and manipulating these phenomena that already exist. So computation would be entirely different. And that's again, it's not to minimize what's being done, but it's an alternative route that I think will yield very, very different results. And it can't be ignored in the scheme of things. It has to be, attention has to be put on it. And sooner or later, there's going to be, because sooner or later people will realize that it has to be done. So it's just a question of time. So
you mentioned two other qualities other than entanglement and superimposition.
Yes.
What are the other
there's tunneling and annealing, which are
tunneling
and annealing. I haven't mused about those in the cosmology of.
Okay.
I've written about it.
I'll just put that away for another.
Yeah, that's more. It's more technical, but it's also. I wrote a paper with somebody that was accepted as an IEEE publication that actually draws a relationship between superposition, entanglement, tunneling, annealing, and the four properties of knowledge, presence, power, and harmony. There's a one-to-one mapping. So again, the idea being that if you want powerful computation to take place at the quantum level, you have to leverage all four of these mechanisms that exist naturally, and you have to use them differently. So you don't have to create them. You just have to recognize them and use them.
So the bottom line for me is that you're talking about, it's like if you were looking at something and you saw a pattern that no one else saw.
Yes,
It's
exactly.
kind of like that, that you're saying this already exists, but we're not seeing it.
Yeah.
And therefore, the other model is missing this opportunity.
It is, yeah. It's
Yeah, okay.
it's not to minimize the efforts of the other model, which
Right.
I
It's
think are very
complementary.
valuable. It's
Yeah.
different though.
Yeah.
It's going to
very-
yield different results. And my bet with the whole idea of going the pattern route and so on is that, in fact, this will yield very powerful results that other ways in which quantum computation is being proposed won't yield, because you're constrained by digital thinking in the way you're thinking about quantum computation. Currently, when you think about quantum computation or the way quantum computers are designed, you're constrained by the way digital computers are designed, or what they do. So your thinking is very narrow. And what I'm saying is that let's strip that apart and just ask fundamentally what's possible with quantum computation. What kind of device could you create to then use these phenomena that exist already, rather than try and constrain it to a digital paradigm? So it's different.
Yeah.
Right?
Mm-hmm. Makes sense. It's rather sort of, a breakthrough concept in some ways, we use that term, that thinking outside the box. Well, this is a real example.
Yeah, I think so. The fascinating part to me is that, again, in all the research I've done, this kind of thinking has never been expressed. So either the thinking of having 4 organizational principles by which matter arises, you don't find it anywhere. And that's something I've written about adequately. And the second thing is also about quantum computation itself, is if you consider that these things exist naturally, your whole design of quantum computation is going to be entirely different. And again, nobody's explored that avenue at all. So these are 2 big gaps for me, and you bring them together, and you essentially can create something fundamentally different. So
to what extent, I think I know the answer already, but to what extent does measurement come into play, or observation come into play when one's dealing with these?
Yeah, I know we've talked about that, but it was, to me, it's a question of the model that you adhere to. So the quantum computation that exists today is largely driven by what we've discussed as the Copenhagen interpretation of computation, of quantum computation. And in that interpretation, what you're saying is that the moment you measure something, it collapses into a reality. So by definition, you can never know what existed behind what you're measuring, because the moment you try to perceive it, it collapses into something you can perceive. Right? I mean, so measurement in the current paradigm of quantum computation is going to never give you insight directly into what's happening behind the veil, because you're always looking at something that's popping up, and then through statistics, you're kind of saying, okay, I'm going to take 100,000 measurements, and if I see a pattern in that, that's going to help me intuit what's happening behind the veil. Right? I mean that's a current paradigm. And so that, measurement, the way that it's considered is that now, in my perspective, measurement is going to be different, because I'm saying that fundamentally these things that you think you can, that you need to create, already exist. Superposition, entanglement, annealing, tunneling. There's already operative at the quantum level organizational principles by which matter arises. And so there's a dynamics that's already occurring that, by definition, when we take Copenhagen interpretation, we're saying we can never find out what those dynamics are. But I'm saying that, in fact, these are the dynamics. So let's begin to build differently if we understand that these are the dynamics. And we can prove it out, but pretty simply. It's the moment you create a device that becomes like a microscope, and you begin to interpret phenomena completely differently because you're seeing differently. If you can't even see differently, you can't even interpret differently. And the problem with today's quantum computation is that we don't see beyond how we're seeing. We're trapped by digital thinking. We're trapped by the Copenhagen interpretation, and we're not moving beyond that. So I'm just saying, let's just move that aside and just think about it from first principles. And I think, in a sense, it's a blessing I'm not a quantum physicist, because I would never be allowed to even say anything like this if I were, right? But the thing is that if you don't have the constraints of those views, then you can begin to see differently, and you begin to question differently, and you can begin to imagine differently. And that's, I think, the possibility of the quantum computation that emerges from a cosmology of light point of view, because I'm not constrained by the thinking that is mainstream.
Which is part of the brilliance of Margaret, because she's going to illustrate your brilliance.
Yeah, and by the way, you've got to see some of Margaret's work. It's amazing. So
I'd love to.
So that's what's interesting, though, Sam, what you're bringing up too, is we're talking about perception in some ways, right? And Pravir, you're asking some questions about removing some fixed perspectives, right? Before you're coming up with an outcome because of a fixed perspective, and you're asking us, okay, well, what if we don't accept the Copenhagen limitation? We don't accept. And then the way I would interpret that is when you say, well, you don't know what you're not seeing. Well, from my point of view is, how can I see this if I don't get rid of my fixed perspective of what does, even in my limited view of what quantum computing is? But for me, what's important, Pravir, is you give permission, right? Because most of us are coming at this kind of limited, right? I'm not a scientist and this and that. However, that doesn't mean you can't do this. And I think if there's the one thing I'm wondering about the folks that were signed up that didn't actually sign in, and I think it is this, I don't know this, I don't know this, I don't know this. Ooh, maybe this isn't for me. And if you record this, I'm going to say, don't worry about that. Don't worry about that. Yeah. You could get that another way, but at least consider going beyond what you think. That's good. Because then this might be able to percolate into you, is what I'm trying to say.
Yeah, exactly. And I didn't think about it, because actually quite a few of the people who signed up were from academia that I don't know, and they were from different countries as well. But I think probably being recorded didn't help, so because then there's points of views that might, if somebody were to say something as well, it might. Well,
I'm just suggesting that there is a kind of a huge leap of, let's say, being neutral or being open that I would suggest. I mean, even I've read those things that you suggested, but if I wasn't open, I can't take it in. And so this is what's important about coming into this forum, is that you're suggesting, so maybe you didn't understand that, okay, but are you open to this idea of beyond a fixed perspective of the way we've been thinking about this and the way we've been computing? And I think that's going to be key for folks to kind of let their guard down and not react with, oh, don't take that away from me. That's a fix. I'm holding on.
I get it.
Yeah.
You might consider doing it without recording at some point. some.
Yeah, yeah, that's what I was thinking. I won't record it next time. So
Yeah.
at some point, so not because, yeah, exactly. Because especially if there's people who are interested or intrigued, and from their emails, I could tell they were from some interesting institutions, it seemed, but I think recording it probably didn't help. So
Well, to it, listen, I feel we all have this. It's hard to admit what we don't know, or we don't deeply know it, and hard to like, okay, I can still let go of that and take something else in. I think that's a whole process. I think that your work, you're up against that, Pravir, I think, because you're presenting something so seemingly, for most folks, coming at it from a different view, put it that way.
yeah.
And so people have to, deal with that in some fashion. And I think it may be formidable for some and less formidable for others. And that's where I think the repetition can be helpful.
You're here.
Thanks.
I'm a big believer in this repetition, because really it's sort of, I feel like a little bit, it's like immersion, just letting it come in. What does it bring up? What does it activate? What's in the way? What might not be in the way?
Thank you, Margaret. Well, before you were almost at the top of the hour, and I'll end in just a minute, but anybody like any concluding comments? Anybody like to share anything before we wrap it up? So
I really thank you for doing this. It's been very helpful. I would love to read more about tunneling and annealing when you get to that point. The keeping the symmetry and the quadrility of all the work that you're doing, and I appreciate your having done these papers that you have cited, the ones that you've cited plus all the others, because they do help, in addition to the books that you've written, give a good sense of where and on this mapping each of these concepts lies.
yeah, thanks, Sam. And yeah, I've written a little bit, which has been published by EEE on tunneling and annealing as well, but they're pretty recent papers. So those ideas have come up, and I'd venture to say it's the first time that somebody's interpreted it the way that I have, but it's different, so.
I just appreciate that you can talk about sort of the state of where things are in terms of quantum computing or in mathematics, so that you can at least kind of have a place to stand and go, okay, but that's going in this direction. This is a departure. So you can see it in relief kind of way, right? Yeah. So it makes it clear for me. It's like, oh, this is this view. This is this view. And not that they're opposed, but it's like an expansion here. So that's, it gives you more reference. It gives it additional context. So that's helpful.
I have a question for a future seminar.
Yes.
Which is relating all this to our concept of dark energy and dark matter. I think
absolutely.
It's really, really interesting to hear how you relate that, because I feel like there's a lot that's unspoken there.
Yeah, absolutely. And I've actually written about it quite a bit, but I've not put it in the musings. I've not published a paper on it academically, but it exists. The idea of dark energy and dark matter is fundamental to the cosmology of light, which I've interpreted differently. So I can do that, so we can set up a seminar that focuses on that as well. So cool. All right. Thank you both for.
Thanks very much.
And yeah,
more to learn, more to take in.
Enjoy the Big Island.
What's that?
Enjoy the Big Island.
Yeah, thank you.
Yeah, and I'll send you that link.
Yeah, thanks a lot. Okay, bye. Have a good one.
Bye-bye.